Okay, curves given by here. It says state the values of A and P, means I don't need any working out to do, but I will, because I need to see what this graph looks like. If I start with y equals sine x, it comes up here. I'm just going to draw that bit. So I'm going to draw the bit going from this point here, which is minus pi over 2 minus 1, all the way up to this point here, which is 90 degrees, which is pi over 2, 1. And if I met that's y equals sine x, and now as I reflect that in y equals x, which is say like that, and it will now go to this bit, so that bit will reflect over, and it's going to do sort of like that. Okay, but the key point is that when you're reflecting these things, the coordinates switch. So this will now become the point 1 and then pi over 2, and this point here will become minus 1 and minus pi over 2. Right, so that's what I've done now, is the blue curve is sine to minus 1 of x. Now what happens to it? It's stretched up by 8, so it's stretched up in the scale factor 8 in the y direction, so it's stretched up and it's stretched down by scale factor 8. And this bit here is translated, so it's translated and it's by 1.5 in positive x direction. So the blue one here was minus 1, and I've got to add 1.5, so that'll be A equals a half, and B equals, this one here is 1, it's got to be moved, sorry, yeah, this one here is 1 here, it's got to be moved 1.5 to the right, so B equals 2.5. That does the first bit. Hopefully that explains why it works. Right, so we've now got to find this, so part 2. Required to find the roots of this, and got to show that it's between 1.7 and 1.8. Or what I would do is I would put it so it's all equal to 0. Sinus 1 of x minus 1.5 minus x equals 0. And then I'm going to try when x equals 1.7, we get it equals to negative 0.089136, and when x equals 1.8, it equals positive 0.63754. Therefore, sign change, therefore solution between 1.7 and 1.8. Good. Got to find in order to find the root, the iterative formula is going to be used. Okay, so but the iterative formula here involves sine. It doesn't involve sine to minus 1, so I'm going to have to rearrange this expression here to, or the equation, the initial equation, to get us. So we're going to start with x. That's what we're going to have, xn plus 1 equals p plus sine of q xn. And so we're going to start off using this expression here. So it's going to give us 8 sine to minus 1 of x minus 3 over 2 equals x. And instead of having this bit being the x which gives us the iterative formula, we're going to take it this x. So first thing I'm going to do is divide by 8. So it gives me sine to minus 1 of x minus 3 over 2 equals 1/8 of x. Get rid of the sine to minus 1, so therefore I have to sine both sides, so that gives me x minus 3 over 2 equals sine of 1/8 of x, which is good because that's the whole thing I wanted. And now I want to get rid of the minus 3 over 2, so I get x equals 3 over 2 plus sine of 1/8 of x. And that's what we wanted. So it says determine the values of p and q. I might as well write them down. P equals 3 over 2 and q equals 1/8. And we've got to work it to 4 significant figures. So I'm going to have my first guess equals, well, it's between 1.7 and 1.8. So it makes sensible that I'm going to have x That's 1.7. First thing I'm going to do is put 1.7 and press equals on my calculator, and therefore now 1.7 is my answer. And now all I have to do is put down for myself this expression here. So I have to do 3 over 2 plus sine of 1/8 times by the answer, and that where every time I press equals, it's going to give me the next step. So if I do that, I get x1 equals 1.71090, x2 equals 1.712236, x3 equals 1.712399, x4 equals 1.712419. I can keep on going. x5 equals 1.71242, and therefore x equals 1.224 significant figures. And actually anyone in their right mind would just press the equal signs until such time as the number doesn't change, just to check it doesn't round itself up or doesn't move up. And that's 6 done.